Hey there, I'm Gerard, and I'm going to be teaching you a little bit about swords and bullets. In superhero movies such as X-Men Origins, Deadpool, Deadpool 2, our heroes dramatically slice bullets in half with a katana. And so I wanted to ask myself, would this work in real life? So, to explore this, I'm going to be using a clip from Deadpool 2, and we're going to be going through some motion sciences, kinematics, and reaction times to see if it's possible for our superheroes to cut bullets in half in real life.
Well, like Scoutmaster Kevin used to say, there's a first time for everything, son. Hey, give me your best shot, One-Eyed Willie.
Okay, so we got to set the scene to do the science on if the PSI is going to be high enough to cut the bullet. So we're going to start out with the width of the katana, which is going to be about 6.35 millimeters and about half this at the tip. Now, the weight of a katana is about 1.5 kilograms. This is pretty average. And the firearm that Cable is using is a real-world firearm known as the Walther PPQ Q5 Match, which is a 9mm pistol. Now, the bullet of a 9mm pistol weighs about 9.525 grams, or 147 grains. Now, at the tip of the bullet, the width is going to be about 4.5 millimeters. And the speed of a bullet fired from a 9mm firearm is going to be about 370 meters per second. And we're going to assume that the distance traveled is about a meter, as they're kind of point blank with each other. Now, we can move into the formulas needed to analyze the science. To explore this more in depth, we're going to be talking about shear stress. While shear stress and pressure are very similar use cases, more specifically we'll be exploring it to attempt to see if the bullet would really slice in half. Shear stress is used when testing tensile strength. If the shear stress placed upon an object is greater than the tensile strength, the object will break apart from itself, or in the case of the bullet and the sword, will be cut in half. So to emulate shear stress, we'll be using three formulas to calculate if the two interacting forces of the bullet and the katana will create enough pressure to overcome the bullet's tensile strength. Essentially, the smaller the area and the higher the force creates a higher pound force per square inch, or PSI. This is why thin knives are better for cutting. Now, we're going to discuss the three formulas that we need to use, and that's going to be pressure is equal to force divided by area, that force is equal to mass times acceleration, and acceleration is equal to initial velocity minus the starting velocity divided by time. These formulas will help us get the PSI, and if it can overcome the tensile strength of the bullet. As the math takes quite a while to actually do, I'm just going to explain how we get each part of the equation, and show a time lapse of me filling in each piece in the background. To find the pressure that was exerted on the bullet, we first need to find the force of each object. Force is found by multiplying mass times acceleration, and these two things we know because of the assumptions and information from the previous sections. As Newton's third law states that each reaction has an equal and opposite reaction, the bullet will exert its force upon itself. So we have the force from the bullet and the force from the katana, and that gives us the total force exerted on the bullet. We divide that by the total area, which we can easily find by multiplying the width of the blade by the width of the bullet, and we get the final answer, which we'll explain a little bit more in the next section. Now, as standard brass has an average tensile strength of 18,000 to 40,000 psi required to cut, this does put us in the ballpark of this working in real life, as bullets brass would generally be thinner as there's less material. However, there is the issue of Deadpool's swinging speed. Earlier we assumed Deadpool swung a sword at a 20 meters per second rate, which is very fast for a human swordsman, but this is not equivalent to the bullet's 370 meters per second. The real issue with this scene comes down to human reaction times, which we'll discuss in the next section. We need to discuss a little bit about human reaction times and why this makes this scene impossible. The average auditory reaction time for a human is 0.17 seconds, and the average visual reaction time is 0.25 seconds. As we mentioned, the bullet only needed to take 0.0027 seconds to reach Deadpool. There's absolutely no way he would be able to react to this fast moving of an object, and he would have needed to predict it exactly. This is why this scene doesn't work, although it is interesting that a katana can slice brass in half in this situation.
So, thanks to our pressure equation and what we know about shear stress and tensile strength, we did come to the conclusion that it would be possible for Deadpool to cut the bullet in half. The main issue is we found, is that the reaction time for him to swing the blade and intercept the bullet is impossible, and he would have to predict it. So, while the physics works out on cutting the bullet in half, unfortunately, Deadpool would need to have a supercomputer of a brain to actively predict when and where to actually slice the bullet in half. Thank you.